Welcome to Handmade Hero Show, where we code a complete game live on stream. Yesterday, so I'd wanted to do some camera work yesterday, but I actually ended up going and doing something in the entity creation system, because it turns out we had not, our world generation code is still pretty rudimentary, right? We haven't spent a whole lot of time on it. It's something we're going to spend more time on as we go forward, but we really just haven't spent a lot of time in there because we haven't been focusing on that. And so one of the things that we didn't have was the ability to tell the world generation, look, I want to place an entity next to another entity, or these two entities have to be in this relationship to each other. Like this one has to be to the north of that one, or this one has to be above this one, or whatever. So we added that yesterday, and it went pretty well. And the reason that I added that was because I wanted to have a test for the camera system to see if it could do things like place a square that you hop on and it would zoom in and then hop off and it zooms out. So for things like talking to another character or things like that. I don't know whether we're actually going to do this in the actual game. Again, it's just exploratory. And this is an educational stream, so when I see opportunities to do something in the code base, I do them, right? That's generally the rule. So I don't necessarily know how much we're going to do with this, with special cameras. We may decide that they're too distracting, or they don't really work very well from the standpoint of the player being able to, the player doesn't really want to do that. They don't want to have this happen to the camera. But I want to put it in and see. And so since I knew that we would want a bunch of stuff in the game that had to do with entity placement, separate from this particular problem, I figured it couldn't hurt to put this in because we'll use the placement part even if we don't use the camera part. So I'm going to go ahead and show you what I'm talking about. I believe at the end of the last stream we just tested this out by saying that we needed to have a cat placed to the side of, above each of the little orphan heads we had put down. And if you see, it appears to work just fine. Like there's a cat above each of these, right? You can see the cat each time. And so that worked great. So now what I want to do is I want to push forward on that and instead, all right, let's create a thing that makes a place we can have the character stand. So we'll have an orphan, and we'll have them facing downward, and to the south of the orphan, we will have a square you can hop on that zooms in, okay? So that's what I want to do in the world generation code right now. So if I go into Handmade PRJ, and I just rebuild everything so I know we're starting from a good, clean place, I'm going to go into the world gen code, and I'm going to go into the entity gen code, and I'm going to see if I can make that happen. Now, we sort of have a mix of code in here. This is sort of the old code that'll probably go away eventually, and this is sort of the new style code where we basically have a callback system where we can, well, it's not like callback. It's more like a service system where we basically say, this is the code you can use to create any of this type, and they're interchangeable. So you can pass a pointer to add cat, add orphan, add whatever. And so in here, we want to add a talk square, basically, like a thing that says, here is something to say. And I don't really know exactly how we're going to do the talking part of it, because that's really not the part that I'm focusing on at the moment. So I'm not sure what I want in terms of the talking, but I am sure what I want in terms of the camera. And so that's the part that I'm actually going to try and create. Now, if you look, so this is going to be a, for lack of a better term, a conversation square. So we're just going to call that an add conversation. And in some sense, maybe I should use the term bark. Well, bark's not really what it is, so I am going to use the term conversation for now. It's not a conversation because the user doesn't really pick responses. It's not a dialogue tree. But in the entertainment, it's not really a bark. Typically in the industry, bark is used to refer to something that is said out of hand by an NPC. So for example, if you might be playing a stealth shooter and a NPC is patrolling and you make a sound and the NPC goes, "What's that?" or something, right? Or, maybe just the NPC is just patrolling and it goes, "Gosh, I'm bored," or "I wonder what's going on over there," or things like that, right? Just just random stuff they say that doesn't really have a specific part in the narrative, right? It's not like something that a script writer was thinking went in some kind of a story progression or narrative arc. It was just something that gets recorded and can be said at any time, given a certain circumstance, like, you know, guard is doing this or guard is idle or whatever. So it's not really that either, because the player is hopping onto it. So I'm going to avoid the term bark for now, and I'm just going to say, look, I don't know what we're going to call it. We're going to call it conversation for now, and we'll just have to leave it there because I don't have a better word for it. So inside room gen as well, you can see in here, so we make, right here, you can see me making a room camera, right? And it's just a area that says what happens to the camera in that room, right? That's all it does. And it's how we move the camera around in that way. And so what I want to do here is I want to have another way of creating one of those cameras. And what I'm going to do is I'm going to look at what I create here with respect to how the camera gets created differently for the special camera as for the room camera. And then what I'm probably going to do is merge those two things together. So I'm going to like take the camera, the room cam stuff, and then the special cam stuff, and I'll probably make a utility function called create camera volume that does all of this stuff. And I'm going to go from there, right? All right. So if we look at what's happening here, we've got sort of a camera for the conversation. I do want to add an entity for that. I don't want to set any flags on it because it doesn't collide, it doesn't take up space, it's not standing anywhere, it's just a region. If I set the collision volume for it, what I'm going to want to do is create a tile-sized collision volume, right? So whatever tile I'm on, I want to create something that occupies that entire tile, so that when people are on it, it does this operation. Brain slot we may want to do something with, but I'm not sure, right? And then when we call this function here, get camera offset z for dim, that is the thing that tells us how far we zoom in on rooms, right? And so looking at this, our minimum is like 13 that we zoom. And so I might just set that offhand right now to 10. And furthermore, I might even do something a little bit more specific here, which is to say maybe I'll make that a call. Get camera offset z for close-up. And that way I know that when I call that, anyone who is trying to do something like that will call this, and then that way I know where it comes from. You know, just to make it a little clearer, so that there's not just a 10 sitting around in the code. And in the future, we might be able to pass parameters here to the extent that we care about them. So we'll see, right? So anyway, if you look at what happens here, the special brain slot for type brain room, you know what I mean? That is not really something that we want to specify here because this isn't a room entity. And so if you look at the brain, oops, I don't know how I hit the caps lock key there. If you look at the types of brains that there are, this may be something that we mark and where we maybe just want to say like this is a some kind of camera brain thing. And the reason that I might want to do that is because inside the simulation system, when we're updating the camera for a particular movement of the entity, what you can see in here is normally we just look to see whether this thing has any kind of camera behaviors set to it. And in the future, we may want to just only look at entities that have brain type camera associated with them. So again, I don't really know to what extent I want to do that, but I might want to do that. On the other hand, another thing we could do is this, where we say that it's a conversation type. So again, I really don't know what we want to do here. There's just things we could do here. At the moment, I guess I will just say, hey, maybe I don't really need to do either of those things just yet. I'll just set the camera behavior to change the offset and we'll call it a day. because just looking through that code there, I just don't see much reason to. So those are the things I considered, and I guess I can't really say that there's much reason to do them. So I think I'm going to just avoid it for now. So if I look at how this is working here, what I now need to do is just get the coordinates into play. And so if we look at what's happening here in terms of what gets passed when entities are created, what you can see inside the world gen code, what I meant to say was room gen code. What you can see inside the room gen code is when we go in here and create pending entities, we are going to pass them the location, and we're also going to pass them a reference that says this is what you're standing on. And so we can do a couple different things here, but at the moment, I suppose the easiest thing to do would really just be to do a rectangle center dimension where we create a box that's just kind of based around that p-value that we get passed. So inside the entity gen code here, where you see us getting this p-value and then the standing on value, we would start with that p-value as the center of the box that we're going to create. Excuse me. And then we'd create a dimension for it. So here's the dimension that we want to make. And I don't really know how big we want these to be at the moment. So I'm just going to create something that's small like that. I'm going to give the dim here. And since we want this to be resting on the ground P, what we would do is say we want to create a offset in Z that happens to be whatever half of this is, so that it's basically a rectangle off of the base, right? And I don't know if we have a math for a grounded rectangle like that, so I'm just doing it manually here, but in the future we should probably make some math for that, I'm guessing, because that's a pretty typical thing to want to do. So if we set the collision volume equal to this, we set the behavior equal to offset, and we set the offset equal to whatever that close-up zoom would be, then when we place the entity, again in here, I think we don't really have to do that. We can just say, look, place the entity at the P that it's at, like this. I think that's really all we have to do. And again, I don't really need to call that anything other than entity in this case, because we're just creating that one. So if we add a conversation, this will add the close-up for that conversation. It won't do anything else, though, right? So it's worth noting that that's the only thing that will do. Let me go ahead and expose this here so people can call it as necessary. Also, don't ask me why these aren't coming first, because normally they do. So that's what that's supposed to look like, but for some reason it didn't. So anyway, that's the long and short of it. Now what we would need to do is just request that thing be added. Now, what I want to do before we do that, though, is right now we would never see that thing. So it'd be really hard to debug. So inside entity, I'm also going to make it so that we turn on drawing the bounds of these things. And so I don't really remember what this code has to do here, but I'm pretty sure that it has changed because for pushing volume outline, we kind of need a way to actually make this thing to actually draw the thing at the location it's supposed to be, because the entity transform isn't taking effect anymore. So I would need to create an offset rectangle that moves this thing to the location where the entity actually is in the world, which is, the entity ground P, for example, right? And so just creating something that draws those outlines first, I want to make sure I have that, because otherwise I would have no idea where anything was in the world. So I just want to see what's going on with that. And so here you can see me drawing those collision volumes. And what you can see from me drawing the collision volumes, right, is you can see that every room has one and the player head has one that's just kind of a residual that's left in there. We don't use it right now, but in the future we probably will for things like whether or not people hit you and things like that. So if you just look at what's going on there, we get exactly what we expect. And so now what I'm looking to try and do is I want to see, when we make this change, I want to see the orphan have a collision box to its south, right? That's what I'm looking for. And so I'm drawing that because since it's an invisible region that's just going to control the camera, maybe the whole thing works the first time and the camera zooms in. But if it doesn't, I'm in a position where I wouldn't even know whether the entity got created, and I don't want to start from that. So I'd like to have that code path working as something that we have. Now, you can also see in here these if ones, if zeros. Those are things we may want to add to the HUD eventually as well. Because we have live code reloading, it's free for me to just toggle the if on and off. But it's one of those things that it's just like maybe better in the HUD because it's faster. You don't have to go through a recompile to turn it on and off, right? So, and because it's pretty low cost to check, right? Okay, so moving along, if I went into WorldGen now and we look at when we create an orphan. So in here we've got like a place orphan call and we're adding an orphan in here. We add a cat as a constraint, and in here we say like north. I'm going to change that to south. I'm also going to add a tag to the orphan, and I'm going to say that the facing direction for the orphan is going to be 0.75f times tau, right? And that's just giving me rotation around the circle, so the thing will be facing downward because I want the orphan facing downward. Now remember, tau, I have a long rant that I've been building up about tau and pi. Before I started Handmade Hero, and well, when we got to this, when we talked about pi and tau on Handmade Hero, I really didn't have a strong opinion about it. I've been programming with pi most of my career, just used to it. People kind of made the case for tau, and they have a good case. So I said, well, we'll use tau on Handmade Hero. I actually have a rant on pi and tau coming up. It's that both pi and tau are stupid, and we shouldn't be using either of them. And so that's coming up, and I will probably post a blog post about it, but we may go through and rip those out of Handmade Hero after I do that rant. So putting that aside, because we don't really need to address that right now, I'm just going to go ahead and set that facing direction in here so that it's facing the right way. And then in here where we have this tag, I don't need a tag for this, and I'm just going to say add conversation. And so now this should put a conversation entity to the south of the orphan, and then I should be able to see that entity as a collision box that I can then go and step on, right? And so that's what we're doing. And so what I'm seeing here is you can see that that collision box looks nowhere near where it should be, right? So I feel that that is probably just highly erroneous. Like, I've obviously put it in the wrong place or something. So let's see what's going on there. And this is exactly why I did that, right? This is why I wanted to see it, because I knew that this would be a likely place to have that error. Oh, and you can see what's going on here. This is not supposed to be P plus anything. This collision volume is relative to the entity's location, so adding the P would effectively add the P twice. So that was just a typo. So let's see if they're in the correct place now. Right, looks better, to say the least. And so now when we hop into those, I don't actually know to what extent we're actually triggering those properly, but now I can actually at least see that they were placed in the correct position. And now I just want to know whether I'm inside one or not, right? And I don't actually know that. I don't know whether that case is getting triggered or whether it isn't. So the first thing I want to do is see whether that case is in fact being triggered or not. So let's start there. I may need to recompile in debug mode because this will be hard to step through. In fact, let me just go ahead and do that right now. If we go back here, I'll put myself in a position where I can, where the case should trigger. And so if I, in here, go to the builds and I just say, look, give me a debug build, it should keep the state of the game the same. So we should just now have the debug mode. So the speed of updating should slow down dramatically, but the game is still in the exact same position that it was. So now if I go back here and I say, look, tell me if we hit this case, right? It should stop here regardless, because it should stop on the room that I'm in. And so the question is just, do we ever get the special camera showing up, right? And so I'm not sure. I guess I have to kind of see whether the brain slot type equals brain slot room or not. So in other words, I got to see when we stop, are we getting this happening, right? And then when we are getting that, I also need to know, like, when we do entity overlaps entity, I kind of need to see neither of these should be set. So I need to kind of set it to pass only. I need to look at only and pass. So you can see we're never getting here, right? We're not getting an overlap of any kind, right? Now, one of the interesting things about this, and I guess I should check this a little bit more explicitly. So when we're doing entity and test entity, so this is the player, I believe, right? So entity is the thing that we're passing in here, right? So entity, this is the player's location, or represents the player's location, right? It's this. And if you look at the collision volume, what you can see is the player doesn't actually have one, right? There isn't one. It's just 0, 0, 0, right? So you're testing to see whether this P overlaps this test entity in any way. And what that means is we might be in a case where we have to enlarge this thing a little bit more in order to actually capture the non-collision entity of the player, because it's actually a single point. So looking at this, when we do this here, what I think I want to do is I want to do an adradius call, and I just want to expand this thing out by like a safety margin, because it's not going to necessarily include the ground point in its entirety if I don't. And so I just want to take that out of the equation. I think it's that, actually. Yeah. So I want to make sure that those boxes include that much. You can see it's much slower because we're in debug build now. So our lighting here is taking all the time. I should have a way of turning the lighting off for debug builds until we actually have it faster. And so now you can see those include the ground a little bit, right? You can see those collision volumes including the ground a little bit. And so now I want to see if we actually can trigger that pass case now, where the player's position is on the base there. So that, basically. And so what you can see now is we actually do get that, right? We do get that overlap now. And that was just because, again, since the player doesn't have a volume right now, and you could argue we probably should give the player one, but because the player doesn't have a volume right now, that test is only going to work if the volume actually encompasses the entire place where the point could be. And when the player hops into it, if the player hops into it and that point was actually like right on the minimum point of the box, that might not be considered in. I don't remember how we wrote this code, but for floating point accuracy purposes, we wouldn't want to rely on that anyway. So you want to sort of capture a wider area to make sure that no matter where that point is floating point precision wise, it's always going to actually be considered inside. So now we should get that special camera call happening. And the special camera should now be set, if we look at what that's actually set to for camera behaviors, we should be able to see the special camera say that it wants an offset, right? So in here, there's a camera behavior, yeah, right there. And the offset should be set to 10, and it is, right? And so if we come in and actually use that, how did we jump back up there? What? Okay, there we go. I don't know what just happened there. That was a little bit weird. Oh, wait, no, I'm sorry. That's exactly what's supposed to happen. We finish this loop first before we process anything. No, that's all good. I'm not freaked out. So when we check the special camera, now what we should do is this should override the location and offset, and it does. And so that's exactly what I wanted to have happen, right? So now what we need to do is just adjust those settings potentially, meaning that, like, you know, we may want to change how the zoom, what the zoom is focusing on, or how far in the zoom goes. But at least now we've got that element of the camera stuff working, and so we can play around with that a little bit more as we go. So now you can kind of see I hop in here and it zooms in. That's not enough of a zoom. I wanted a more egregious zoom. So I wanted something that was going to be really absurd. So in terms of egregious zooms, what I would really like here is probably something just, that's like really, really out there. Just really bizarre. And so let me now try hopping on it and see what I think of that. So, I'm going to go in to talk to this orphan, and we get a zoom like that. Yeah. Now you can see we also have some problems with the way our camera interpolation is working in terms of that near and far plane. So when we zoom into things, you can see that the near and far planes don't keep up properly. So that's another thing we're going to want to make sure, we're going to want to make sure we solve that in a good way. But this is what I had in mind. So, I'm in this room doing stuff. If I want to talk to this entity, it zooms in like this and, does some kind of conversation nonsense here, right? Now, the problem that I'm going to have, and one of the things that I need, this is why I said yesterday I alluded to this. What I really want this box to be is I want it to sort of encompass. I want this offset to be something a little bit more based on. Well, you know what? Here. I don't really know how I want to solve this going forward because it depends how flexible we want it to be. But let's suppose we're hard coding our conversations to be that facing direction. Then it's pretty easy to do because the camera offset Y can just get modified by some value. So I can say something like this, and then we do that offset, right? And I don't remember whether this is a plus or a minus, so I don't remember which way we interpret the offset. But this would allow me to focus on the conversation offset a little bit more, like so. And that's really more the way I want it, because you want to see the person you're talking to, and you should kind of be at the bottom, right? So that's the kind of zoom that we're more looking for here. And once we've got that, we just need to think about whether we need to parameterize that conversation in some other way to make it so that if you were talking to someone to the side of you, that offset wasn't going to happen that way or something. So again, I'm not really sure exactly how I want that to go. But this is good enough for now. And so what'll happen is when we hop on these, we'll want to have the thing that actually puts up the line of dialogue, and we can look at doing that. But right now, the important thing to focus on is just that camera code. And so now I think I have all of the things that I want in terms of cases for the camera code. And so now the rest of the day, we should be able to work on improving the quality of the camera code. And again, I listed kind of what all those are, but just to give a recap, I want to damp out any like unnecessary movement of the camera, like following the hopping. I don't want that. I want it to be smoother. I want to try and fix the interpolation of the alpha clipping so that when you zoom in on things, the alpha clipping doesn't go ahead of you, right? Because that's a problem right now, and you can see that really clearly in this case. There it was there, and here it is again here, right? It's that slow interpolation of the alpha fade distance really doesn't work with the speed of the camera movement, so we have to get those two things locked together better. And then, yeah, right, you can see like it's really bad there, right? And so we want those interpolations to happen concurrent so that you don't, you want to look like that, right? What I'm doing right now. You don't want it to do the other thing. So we have to fix those. And then the other thing that we want to do is we want to make sure that we have a debug camera again. And we don't have that right now, right? We don't have any way to go into debug camera mode. So those are plenty of things to keep us busy for the rest of the day, at least on the camera. And so I'm going to dive in on those and get working on those right now. I'm going to tackle those in the order that I feel like they're actually existing right now in terms of problems for me. Oh, actually, there's one other thing we have to do. We also want to have something for the camera where we can solve for the light volume. Like right now, you can see the line where the lighting stops. We want something that actually correctly takes a camera frustum and puts all the things that should be lit into it. And right now, we don't have that either, right? So yeah, so really what I need to do is tackle these in that order. And like I said, what I want to do here is I want to focus first on that weird interpolation problem. So the first thing we're going to focus on is getting this to work properly. The camera looks just fine, but the alpha plane clipping, the alpha value, totally gets wonky, especially if you're hopping in here for the first time from like something where the alpha was really far before, and then you kind of hop in here and do a zoom quickly. You can see you get a lot of problems there. So I'm going to start with that code and see what we can do about that. So inside the sim region, we have the way in which the camera is getting updated. And you can see in here, for update camera for entity movement, which we were just in, you can see in here where we set up the things that we want to know, we actually have like explicit ideas about what we want the focus min-z and focus max-z to be. And we know where we think the camera should be. And then we had some rather crappy interpolation set up here where we would interpolate those things. And we just did a proportional derivative controller for this, which I think is the only thing we really could figure out that was going to work in a reasonable amount of time. That wasn't going to be a huge math adventure. And then here, all we did at the end of the stream when we were doing that is just slapped a proportional derivative controller on that as well, the target expected focus values. And so the question is there some way of measuring this so that the z interpolation of this and the z interpolation of these is more commensurate? Because really what we want to know there, to a large extent, is we want to know that our z clipping values, so our min-z and our max-z for like the room focus and the entity focus, right? We want to know that those values are tracked essentially one-to-one with the motion of the camera. And the problem is we can't necessarily map them directly to the camera because we don't have the requisite information for that. At least I don't think we do, right? Meaning, because we don't really know exactly what the camera's location, like we don't really know where we were coming from because that's constantly sort of changing in a way. It's continuous. We don't know how quickly we can set the target expected focus min and max to be their new values, or rather the expected focus min and max. We don't know how quickly we can set them to the target because we don't know how much the camera has to move before those things are valid, right? We know how far away we are from it, but that's all we know. And so I'm not sure how to really measure that, right? And so that's a little bit tough. Now, there are some things that we do know. So we do know, for example, we do know if we wanted to make these things be inline more appropriately, we do know that we could eliminate some parts of the camera in terms of updating these, right? So if we were to, let's say, right, that we were to remove the expected focus velocities. So what if we just got rid of those velocities? Because let's say that we just don't think we're going to be able to quite make these two be harmonious if we constantly have to keep matching their speeds or something, right? So if we were going to do that, then the first thing that we could say here is, look, if the camera has arrived at its target, right? Which we know is true because you can see these two cases are different, right? So here's the one where we stop and we lock the camera to the target. If that's the case, then we want in here to have an expected focus min and expected focus max. We want those two values to be hard set there as well, right? Meaning the target and the expected should equal each other at the time when the camera comes to rest at the final location, right? So we kind of know that happens, right? So now the question is kind of like, well, so if I look here, the question is, what should I do about updating these in the case where we haven't done that, right? So in the case where we're still updating the camera's motion, right? The camera's Z delta or whatever else you want to talk about that. Where I'm moving the camera in Z still, potentially, I want these to be in operation, right? And so I kind of want the amount that we update those to be proportional to how far we are from the target, in a sense, right? Meaning the update step for the expected minimum and maximum values, I want that to be commensurate with how far we think we have to go, right, to get there. So what I could do is say, what is the proportion in Z? In fact, you know what? I think I can do this pretty cleanly. So what I'm going to try to do here is I'm just going to mathematically tie these two things together more explicitly. We know what the delta P value is, right? And so after this is done, like after we take that step, we would then know how much of a step we took relative to the Z value of these two things. Trying to think of exactly how. I suppose I need to actually keep that in place, so I guess I will leave it this way. But basically what I want to do here is I want to update these two based on the ratio of their difference. So their ratio of their difference to the step size being taken for the length, right? So in here, I'm going to take these lengths. So I'm going to probably bite the square root here. So I'm going to say delta P len and I'm going to say total delta P len. And so here I'm just saying, look, this is the length of those two things. I can still say if the delta P length is less than the total, then we'll do the step. Otherwise, we won't, right? So that's all good. But then what I want to do is in here, if we're going to take a step, then what I want to do is I want to do the delta min Z and the delta max Z. I want these to be computed based on that ratio. Okay? So there I've got the target min Z. That's what I'm trying to get to. I've got the expected focus min Z. So this is the range that I have to cover to get from where I'm at for min focus Z to where I want to be, right? And I can create a ratio between that and the difference between these two, right? So this is the length difference, right? Maybe I'll call this the P-span, right? And so that's just, this is how far I have to cover in terms of my total length, right? And so the difference between those two amounts of coverage I can use to figure out and how am I trying to say this? I know that I have a certain amount of distance to cover to move the camera from one point to another. I also know I have a certain amount I want to cover in terms of focus min Z, max Z. I just need to take the delta I'm doing in one and map it to a delta in the other, so I know they will always arrive at the same time. Does that make sense? Now, all right, you know what? I take it back. I overcomplicated that in a bad way. The focus min Z and max Z only depend on camera Z distance. So actually, we should only be measuring the Z distance anyway. So here, technically, I can just do Z span instead. And what that means is if I take the total delta PZ, that's how far I have to go in Z. That's really all I need. So then the delta ratio here, so the amount I'm going to go versus the amount I have to go is just obvious, right? It's just that. So that tells me how to map from a spatial motion, right? Because it says, here's the total spatial distance, and here's the distance I'm going to go, right? I can use that ratio to map things that aren't spatial, that were in the focus min Z, focus max Z. I can use it to map their deltas, right? Does that make sense? And so setting up the math here, if I wanted to know how far to go here, I just need to create the spans for each of these. So this is the min Z span. Right? There's the difference there. That's the direction I'm going. And that can be negative, right? That's actually fine because it's allowed to be negative since we can take steps in a negative direction. So I don't care if there's a sign in there. That's totally fine, right? This will never be negative because these are lengths, so they have to be positive, right? Oh, well, no, that's not true. So this actually needs to be an absolute value because we're checking the Z's directly, right? Yes. Oh, except that I don't really, because that Z will also be going in the same direction. So actually, I know that those are both the same sign, so it'll always cancel. That's a little nasty, but you see my point, right? So now what I need to do is just from these two spans, I need to figure out how to produce one of these, like a delta for these. So I need the delta min Z and the delta max Z there, right? So I just need to be able to do that mapping. So I want something in the focus space here, right? I want something in focus min space. And I have a delta, which is delta PZ. That's the amount that I'm actually going in space, right? So this is the percentage of the distance I'm going, right? I'm going this delta percent, right? I mean, you could think of it as this. I'm going that much. So if I just take the total amount I have to travel in either of these and multiply it by that value, then I will get the amount I should move to make sure that these two are commensurate, right? Now I know that's a little squinky, but you get my point, right? So hopefully we can tune that and to get correct Z that updates at the same rate the camera's updating, so we don't have that problem, right? And you can see already it cleaned up all of that lag that we were seeing in the alpha plane clipping. Now let's do the real test. Let's go down the stairs and make sure that that actually works, because that's the place where the Z clipping really gets stressed, right? So let's say I hop down here. Beautiful. Right? And so again, so all I did there, right, is I just used the math to tie those two values together. And you can see, oh, it's just great. So that just removes all of that from the equation. You can see why I preferred that solution, right? By tying the interpolations directly together, I don't have to fiddle with a bunch of knobs to try and make sure that I got it right. And now it just can't be wrong. You know what I mean? Because those z values are locked together. So as long as they're set to reasonable things at their start and end point, I don't have to worry about what they do in between so much, right? And so that's really, yeah, so that's really great. I'm really happy with that. I think that's very nice. All right, so let's move on to other stuff here in the second hour. Debug camera probably wants to be its own day, so I'm not going to do debug camera next. Well, maybe, whoa. What did I do there? All right, so to be fair, maybe this has a bad bug in it somewhere. You know what? If this z is 0, this would blow up. So there is one issue here, which is that this code path really wants to exist, right? Meaning if these two things, if the total delta p z is not at least a nominal amount, like if this is going to be some really fractional thing, then we just hard set it, right? Because that's a divide there, and this value can't be 0, and it might be. So we need to take precautions when you're going to interpolate from one place to another, and the z's are identical. We need to just say, okay, we pretend we're already at the target, right? I think that's all correct. So looking at these two, I want to say this, now that it's got that check, can also be pulled out. So I think this is also correct, meaning we can just always look at the total delta p and use that to make our decision about whether we're going to do either of the two interpolations, and we don't need to nest them, and that way we don't need to repeat this case twice. So I think that's just a little cleaner. Yeah. So I think that's good. That seems good. Oh, but no, that was not good. Oh. Helps if that goes the correct direction. Basically, I said, if it's a large change, don't interpolate it. I'm like, okay. I probably want that the other way around there, Case. All right. Let's just double check that we don't have any issues there. Just try to slide around here a little bit. Yes, very good. Positive development. All right, so this is feeling great. I'm loving this. The camera feels really nice. Again, there's a little wobble in there. That's the thing that I wanted to go address now, right? Is that I wanted that smoothing. I don't want it to do that. I feel like the z distance is a little high right now. So if you're on this step, I don't think you should be seeing that. So I feel like the actual clip z distance is not quite set correctly. So like in here, right where we're setting these, I feel like the alpha distance is probably better set to something a little lower. You know, problem is that's really touchy with how far that goes. Let me see what I think of this. I'm going to play with this a little bit. So I don't really like that as much. I think maybe what I want to do here is say, so when you're on the ground like this, the problem is these things have a Z variance in them. And so as you go up and down, it actually is changing that alpha clip with every height change there. And so it's a little bit tricky for me to think about how that should really go. I don't know. But I'm tempted to just leave it as it is, because I like the effect, and if there's occasionally things that sort of alpha in or out, we could probably do some clamping where we threshold the alpha values, if need be. Sorry, I'm just trying to observe here. I have nothing to say at the moment because I'm watching. Yeah, so I don't know. I think those values might be a little better. 2755 might be more my preference. It's hard to say. Let me crank it up to like 75 and see what I feel like about that. It's a little more gradual. Maybe I'll leave it there. So 275/75 I think might be my my sweet spot there. In terms of like the camera alpha min, alpha max. So I'm gonna change those. We were using those. I'm gonna use 275 and then 75. Just feels a little better, and I don't get some of that ringing. So I think I'm gonna leave it there. And that feels pretty good. All right. So back to our story. Let's talk about how we're going to deal with some of that damping and some other things that potentially might want to do. So in terms of the sort of that buoyant motion, what I think we want to do here, there's a couple different things we can do, right? One is we could track the player's position separate from the hopping. But the problem with that is it will... If we go that route, and I talked about this, I think, a little bit in the pre-stream when someone asked this question. If we start adding additional information in there, but like things that are like artificial things that tell the camera what to do. So, you know, in this case where we're saying this is a conversation, here's where you should zoom. That's a cinematic thing you're trying to say. I'm okay with that. Trying to eliminate the hopping, the bounce in the camera for the hopping by adding something that says, here's where the player actually's ground point is or whatever. I like that less, and the reason is because then you constantly are creating these special cases that we're going to have to think through and deal with separately, such as hopping down the stairs, right? we then have to say, okay, do we just like linearly move the player, or what if there's like some crazy like things they can hop on height-wise in here or whatever. And so I really feel like I don't want that. I don't really want to have this problem of having to constantly have an out-of-band communication channel to the camera that's going to be something I have to worry about. So what I'd rather do is first, and if we have to do it, I'm fine with that. Meaning if we end up having to do it, that's okay. If I can't solve a problem in the way that I would like, I'm okay with solving it in a way that I wouldn't like, right? I mean, I'll do what I have to do to get it to work okay. But first, I would rather see if I can make a filter that just only looks at the player's actual position and then comes up with the answer with nothing but that. You know what I mean? So that's what what I would like to try and do now. We're losing some frames here. What? Who's? Of course, it's just compute light propagation. It's always just compute light propagation. We gotta come up with the world's fastest lighting algorithm. Look at that. It takes all our time. Look at that. Look at this. Look. Look at how much lighting we're doing. It's nuts. We'll figure it out. Don't worry. Don't you worry. We'll figure it out. So anyway, yeah, let's go ahead and think through this some more and see if we can't come up with a filter that will just work. And that way we can just be done with it. And we don't have to constantly be feeding all these little breadcrumbs to the camera code, be like, hey, by the way, don't really follow this motion because it's not important and all that other stuff. So if we wanted to look at the filtering that we could do here, what I might suggest is saying, well, first thing we can do is we don't really have to update the location of the camera if the player isn't too far from where it would have been already, right? So one thing we can do is sort of have a camera mode. Like we could say, what's the camera doing right now? And we could say, well, if the camera has come to rest, we just won't move the camera unless the player has hopped outside of unless the target has moved sufficiently since then, right? So that's one thing we could do, and that would be if we wanted to make it so that, for example, let's say you're in here, you know, and I'm fighting some bad guy, and I'm like hopping back and forth here. Do you see how the camera's like moving like back and forth, just kind of back and forth, even though I'm always staying within a very small area? So one thing we might want to do there to avoid this kind of repetitive camera motion is just say, look, if I'm not far enough away from where the camera already is, just don't worry about it, right? So only kick in the camera acceleration when we actually have come a certain distance from where we last positioned the camera, right? So that's one of them. And then for the hopping, that would mean that the hopping here, where we're doing this, right? We can keep that state separate, meaning the X, the Y, and the Z states can all be a separate state, so that we'll only update those states when they each have gone a certain amount out of the way. And that would keep us from moving the camera for unnecessarily small adjustments, if that makes sense. And so what I'm going to do there is I'm essentially going to have a, for lack of a better term, a camera movement mask might be the way to say it. And the way this is going to work is the camera code, which is this. And by the way, we should probably make a camera file at this point because it's its own thing. Could move, like now that this code is fairly real, we could just pull it out into a separate place where it does its own thing. But, you know, not super motivated to do it, so maybe I won't. I'm going to have a movement mask here. And that movement mask is going to initialize to 0, 0, 0. And what's going to happen is every time I go to compute a camera DP, instead of actually applying the camera DP, I'm going to mask the camera DP by the movement mask value, right? And so when I take this stuff here and I look at like the total delta P, I'm going to say total delta P equals the Handmade product of the total delta P times the movement mask. And remember, the Handmade product is just the component-wise product, x times x, y times y, z times z. So if the movement mask is all zeros, you will never register a camera movement. So if I run this right now, the camera just won't move, right? It's not going to go anywhere. So we won't even be able to start the game. It'll just be frozen in its tracks, right? We will just see a blank screen. Oh, well, maybe not. I guess we came to the first one. All right, I'll be honest, I have no idea how that's working. Oh. Never mind. So we're not actually using this value because reasons, I guess. You can see we never use it. All right. This is supposed to be in here, and we didn't do that. And so, yeah, I don't know what the deal was there. So here we need total delta dp as well. Right? And so this this value also needs to get modified by that, even though it's not something that ever equals anything other than 0 at the moment. Let's try that again. Although it seemed like we're still getting motion from 0, 0. I think I'm still missing something, because we shouldn't be able to move at all if the total delta p and the total delta dp are both zeroed out. Because oh, well, now I think about it, this will always execute. So we need to rewrite this as well. So this also needs to be this. Right? Because if we don't do that, then we will never actually get if we don't do that, then we'll never actually use this condition. Will always hit, because if these are both 0, we will never use the interior loop. We will always use the exterior. So we need to actually use the delta, which has been zeroed out in this case. There's other things I could do there, but that probably is the easiest. And so now we get what I expected to have happen, which is we don't see anything, right? Okay. So now what I want to do is say, all right, the camera movement mask is going to be based on the difference between these two things. And so we're only going to set these in very careful circumstances. If the camera comes to rest, so if it comes to rest in, here, then the movement mask is going to reset to 0, 0, 0, so that it has no movement, right? We're going to check each element here, and we're going to check each element in turn for its motion. And if it's large enough, we're going to set the movement mask up for that element. So each of these, and I'm not going to bother with a for I loop because it would be longer to write than the actual thing. Basically, if the total delta p for whatever this thing is right? If the total delta P for this thing is greater than our movement threshold for that axis. There we go. Wow. Spelling day. If it's greater than the threshold, then the mask is 1. Otherwise, it's 0. Right? Another way to say that... Oh, well, that's not actually what I want. I don't want to set it back to 0. So I really just want to do this. Meaning if the movement exceeds our movement threshold, and I'll make that be per element, so we can actually set the threshold to 3 different values if we want. So for example, maybe the threshold is, you know, a 4 wide box this way, but it's only a 1 wide box in Z or something, right? Who knows how we want that done. But basically that means, look, if the threshold is exceeded, then we turn on camera motion in that axis. If the threshold isn't exceeded, we don't. We turn the entire camera movement off when we arrive at our target, right? Pretty straightforward. So let's debug that. Yeah, that's not right, because that has to go there. Let's try it one more time. There we go. And so now as we move from room to room, obviously we're not going to see, you know, unless I screwed something up, which could have easily happened. We're not going to see any really weird stuff happen there because the camera was locked per room here. But we should see stuff happen in other locations if we, you know, if we did this right. And I can already tell I didn't quite do it right because you notice that. Oh, well, there it is. So maybe I just need that region to be larger. Let's try setting this to maybe like something like 10 that way and 8 this way. I don't know what Z should be. So that's a little bit more like it. Of course, that's now a little too permissive. And you can see it's still doing the bob there, and I assume that's because the Z needs to be a larger threshold. There we go. So now it's just, it lets us say stable there. It still seems like the Y is maybe larger. So why that wasn't working, why is 4 too little but 6 is not? Something's a little weird here. So I think I've got something weird, maybe that I'm not quite understanding about the way that code ended up falling out there. Because something's weird about those settings. They seem to be off. I can't quite see anything, though. Unfortunately, I don't really see what's off. Do you see how dramatic that difference is? It just seems like that difference should be less. And that's triggering my my spidey sense there. I don't really have a spidey sense, but that seems wrong. So I think I'm doing something wrong, but I'm not sure exactly what it is. And so that total delta P value there, where we subtract the target that we're going to, minus the location that we're currently at, that doesn't seem to really be doing what I think it should be doing. And so something is up with that code, but I don't know what. And it just seems like that threshold seems like that threshold is weird. Do we have so we don't have just a general root debug. We're going to have to add that because I'd like to view this value. So I would like to have our little root back again. Although I suppose for camera, it's pretty easy for me to draw that actually under the camera stuff at the moment. But, you know, whatevs. So you can see the thing that I'm having trouble with here is I want to know why these threshold values seem to not be behaving the way I would expect. And you can see that actually very clearly even in the first hallway, it seems. So you'll notice there's no scrolling for all of that hopping. And now inside the threshold, if I was to change this down to 6, it should be like if it was 8 squares before, it'd be 6 squares now, right? And yet I don't see any difference there. That's just so bizarre. Although I guess maybe this room was always supposed to center anyway. So honestly, what it feels like is happening is it feels like we're setting the movement mask to 0 prematurely. Which I suppose is something that could happen maybe if the length of the total delta P... I don't see it. I mean, correct me if I'm wrong, the movement mask once set cannot become unset until the camera reaches the target, right? I don't see a lot of ways that that is... You know, I don't really see a lot of ways that that is able to be circumvented here. And I suppose this... That code is a little squinky, but I still think it's correct. All right, so I don't have any good ideas here. I can't really find the bug by inspection. So I'm going to go ahead and actually get these values debugged. So, you know, if I look at our rendering dump here, I think I should be able to like put some camera readout stuff in there and just kind of get a little more information about that. I can just see stuff is doing weird. I'm obviously just, maybe I've got a typo, or maybe I'm just thinking this through wrong, because that's, you know, entirely possible. So I want to see what's going on, and even just ignoring this code down here, right? I want to know why I'm getting the sort of weird, where these thresholds don't seem to be lining up with what my intuition is. So what I'd like to do is I'd like to draw the camera mask, right? So I'd like to do a debug value of the camera movement mask. And I will put that in a block under the renderer, just so that we know that it goes there. And so I want to get the movement mask, and I want that total delta P. I want that to be displayed here. And I want to see what the movement mask is at any given time. Just so I have some idea of what, and you know what, while we're at it, like, why don't we just see the P and the target P as well, just so I can get some idea of, you know, what those values actually end up being. So if I restart this, I don't know if we had some weirdness there. Let me see, where's renderer? There we go. So just looking at those, right? I mean, it's already wrong. Like, the Y is wrong. It should, the total delta P should be triggering that. I'm doing an absolute value, right? So shouldn't that trigger the movement mask to be set up to 1? Is there something wrong with the way I'm doing the absolute value or something? Let me get the post version of this as well. So I don't actually know how to make a second one of these. In the debug interface, I can't remember if we can just print something out in multiple steps. That's kind of not something I actually know about. So in here where we've got like debug value and we pass the value, it always produces this name. It looks like that name though gets concatenated with the file and line number, so I think it's actually different. So I think I can just do this. Furthermore, I could do this. Think, in which case our debug system should give me 2 separate readouts, one for pre and one for post. Yeah, and so the total delta P here, you can see it's -4, right? Oh, and I guess the threshold is 6. Okay. All right. Touché. So let's say this was more what I would have expected it to be. Well, let's say I move into like here or something, right? So the total delta P in this case, it's saying is 2.6. And that's just not enough to trigger the motion. And you know, you're right. You can kind of see too, like since the Z's are wrong there. It just gets cold set. So these kind of have to be more sensitive than that. Which is a bummer because it means the hopping is still a problem. All right. So one of the things I guess I'm seeing there is that the trigger for the motion of the camera... Gosh, I'm really confused. The trigger for the motion of the camera, once the camera has come to rest, it might be more that this... this value vanishes too slowly. So the this here is maybe not the right way to look at it. It may be that this delta P needs to be able to hit its target a little faster. So like the damping there needs to be less or something like this. So that's kind of hard to say. But I guess the problem is that once the camera gets in motion, sometimes it just stays in motion for a while, like and possibly erroneously, and that may have been something sort of what I was seeing in terms of when that camera mask, like, even though that looks like it's come to rest, it hasn't actually. You can see that camera mask doesn't get reset for a while, right? Watch this value here as I'm hopping around. You can see, like, if I do that, it takes a really long time for that to actually come back down to being set to 0. And so I think, you know, we actually want this to, we want that to have a more definitive finish point that sucks up that small motion. And so I think what we'd want to do here is say, maybe there's like a sort of either or, where we're basically saying, look, if you're going to reach the target, great. That's one way to stop the motion. The other way to stop the motion is if the length squared of the delta P is just too low, right? Like if it's just smaller than some relative displacement we just don't want to deal with anymore. And we could do that for setting the camera mask separately. I don't know how we want to do that. I also don't really know what's going on with that camera position. You can see it's still interpolating. I don't know why. Right, you can notice the camera value itself is actually interpolating. And that's super creepy. That's the actual p-value, the actual position value that the camera is supposed to be set to. And you can see here the camera movement mask is set to 1, 1, 1. even though it clearly should be set to all zeros. Right? Meaning this total delta P, the absolute value of total delta P in this case, is clearly not above the threshold. So we're talking about whether this ever got called, and apparently it just didn't. Meaning, apparently the length squared of delta P is not less than this. We're in La La Land. So I've got a bug in here somewhere that I'm just not seeing, because that just don't make any sense at all, right? Here's delta P. Let's get that in there. We're going to have to restart because these aren't stable. Yeah, I mean, that's the length squared of that is definitely, I mean, it's definitely set to those values. So how is this not getting triggered? If the length of delta P is less than the length of the total delta, or the length of delta P is less than this. Oh, did it again. So what we really want to do is that. I had mixed up those two cases. I should probably move this up into the top case, because it's sort of the way I obviously was thinking about it. Okay, now let's try to figure out what's going on here. All right, so now we have to figure out what this value should be, right? Oops, that's not what I wanted. So now we have to figure out what this movement value should be. And it's basically like if the amount that you were going to move is just too small for us to really see. And I should probably make that be proportional to the time step. So meaning that should vary according to the time step. And so if you were going to move slower than something, right, like maybe 0.1 units per second, then it's done. Don't move at all. Right? So we're still getting some wonkiness there. You can sort of see where that hits in. I don't know if also maybe, I don't know if I really want this check per se, or if I just want to make sure that the camera motion, like I may want to instead just say, look, we can keep this check. We just have to get rid of some of that damping. So maybe this value is like just too high. So we don't really want to damp that deceleration quite so gentle. Like we want it to be pretty dramatic. You know what I mean? That's a little bit too much. So I'm not sure about this. It's been pretty squinky, and I don't love things that feel squinky like that. And you can see that that's still not critically damped. Like, we're definitely getting overshoot in there in the proportional derivative controller, which I definitely don't want. right? You see a lot of that? Yeah, still not. Still getting an overshoot there too. So I don't know. That feels better. That feels pretty good now that we've just cranked that spring a little bit so that it doesn't quite have... Like, that's feeling pretty good. So it may have just been that our spring was a little bit... was too damped, so it just wouldn't ever really get down to... it wouldn't really approach the target. It kind of like over damped, so it always had a bad curve. You can see right there, like, I'm getting that bounce. And the reason I'm getting that bounce is because it still takes a little too long. So it's still, that's a little too damp. It's not hitting the target, as you know. So once I get into a movement zone, I need it to, like, stop, you know. Just trying to confuse it here to see what happens. So another thing we could consider is we could also consider having the movement mask be signed, meaning we won't start going in a direction until you get too far in that direction. Because right now, once I've got it going, I can kind of go back and forth like this, and it will just keep, and until it actually hits a solid state, it won't actually stop, right? And so that part is a little possibly bad. So here's the thing that I think I might propose, thinking this through. I think this might be the wrong way to look at this. So maybe what we want to say here is we also want to look at the speed because that also has to match. So we may want to say, look, if the length squared is wrong, or if the length squared of the velocity because here's this part where we've created the new velocity. And so if I'm going to look at the new velocity and I want to see like what the new velocity would be, you know, relative to the old one there, relative to the target. I might want to sort of get that measured again as well. So, you know, if this, or I should say that, if what we're going to set the velocity to, and I can do that by the camera movement mask as well. If what we're going to set the velocity to is less than, if that difference is less than some threshold, right? And the reason I'm saying that is because one of the problems that I'm going to have is that if you happen, let's say the camera was moving pretty fast in this direction, and then the player was hopping pretty fast in the opposite direction, they might just happen to align, and the camera would just freeze dead in its tracks. You know what I mean? And that's not going to feel good. So I think we also have to check to make sure that the camera itself is not moving too quickly. Because if it is, you don't want to stop it, right? I never want to have that feeling of the camera hitting a wall. And I'm still kind of getting that feeling here occasionally. Let me just see. I don't know if this value might be a little high. And so I kind of just want to try to alleviate that wall hitting feeling. So when the camera's in motion, it can stay moving, but once it stops, it won't start again until you've got a pretty good push. You know what I mean? You can see the camera's like drifting. I think I will set that cold here. So I think we can do a better job on this than what I've done so far. Having explored it, I think I can do another pass on that, maybe next stream. We're close. It's just that needs to be thought through just a little bit more. And you also get some of these things where like we kind of need to know that the camera movement mask in certain cases, like there it's just saying, well, that's not far enough for me to care about, right? But that has to be. So in some sense, you know, you got to set, when you set the focus, we may have to set the camera movement mask up. So for example, like in the case where we have a special camera and the special camera is affecting the XY offset or the Z, we may need to say, look, in a special camera scenario, you got to 111 that. You know what I mean? So the movement mask is automatically set for something where we know we got to zoom in, right? It does not like the overlay window. So yeah, I think I think we want to maybe untangle that a little bit. I'm going to do that next stream though, because I would like to make that a little bit. It's just not quite there yet. It's close, but it's not quite there yet. And so I want to just go through, now that we've got that code in there, I want to go through and give it a little bit more polish. It's very close. It feels really good. It's just I can still feel a little bit of hitches in some cases, a little bit of overshoot and stuff in there. So I think we can do better than what we've got. And so we'll take a look at that on next stream. For now, I think that's good for today. Let's go ahead and go to the Q&A. Let's see. Oops, that's not how you spell Q&A. There we go. Should probably do the work to make sure the glove floats around with you. It's kind of been annoying having it not float around with you. We haven't really done that yet, but like for some reason we just have not done that. You know what I mean? I don't really want to do this at the moment, but I think it's just this. Right. Do I need to set that? I'm not sure why that's not consistently placing the glove piece somewhere. There we go. All right. So I'm not sure where that angle offset actually gets set. Ah, I see. I'm just playing around here. I should actually look at the Q&A. Sorry, the fist was just bugging me. All right, so yeah, we'll do actual code for the fist at some point in the future, but it was just bugging me that it wasn't floating around with us, right? So I figured I'd just make it float around with us for now, and then we'll make it actually do its real stuff later on. All right, let's see what we got for Q&A. Still not sure I understand the reason why you don't store the actual position and smoothly scrolling between tiles and the animation position doing the bouncing. The bouncing should only have to be dealt with during render and can be derived from the actual position, so you don't have to store it anywhere. Am I wrong about that? Well, again, wrong is probably the wrong word in either case, because there isn't a wrong. There's just what the consequences are of doing it various ways. So if you take what you're suggesting to the logical conclusion, you have a lot of problems, right? And what that is any time you want the animation of the player to be something more complicated than hopping from one tile to the other, what do? So let's suppose that the character is hopping from one tile to the other. So you have moved their base position, right, to be underneath where they were, but they're up here, okay? Now they get hit and they're supposed to fly up in the air and stay up in the air for a little while or something like this. Where are they, right? You were lying to the camera about where they actually were. So now you have to construct some kind of interpolation rule about what you do when you transition between your fake position and the real position that the player is actually at, which is what the viewer sees. And so my experience is you really don't want to do those sorts of things. And the reason is because you will always end up producing artifacts that you then have to go and add special code to fix once you have more things happening action-wise than just the one you planned for, right? So if instead you just always do a filter on where the actual thing is that the viewer looks at, it can't really be wrong because it's what the viewer sees. And so basing things that control the camera movement over fake elements that the user can't see, and they're concentrating on something the user can see, right? Because the user doesn't know about your fake camera thing. Then in that place where you have to transition between one and the other, all hell breaks loose. And so I just don't want to deal with that. I just want to have something that will always work for what we actually see, and go from there. What's the plan for lighting on the sprites? So for lighting on the sprites, it will probably depend a little bit on how we finish up our lighting solution, but they'll probably just be adding a synthetic sample point to the lighting solution that just doesn't really occlude anything, or maybe it even will occlude. We might actually put a whole cube in there, and then we'll just light the sprite with the result of the cube. That's it. We won't be doing anything different. It'll still just be cube-based lighting, but there'll be a fake cube for the sprite that you just won't render. And it's not perfect, right? It would be better if we had actual 3D geometry for all those shapes. Much like what I said with the camera, you always get artifacts there. It just, those artifacts aren't going to be that bad because people can't pick up errors in lighting like they can errors in movement. Their eye is much more tuned to errors in movement than it is in errors in light. So. Is the variance of lighting just a side effect of the random sample? Yeah, our lighting isn't great. We need to do a better lighting algorithm. It's too slow and we don't get good enough results for how much time we're spending on it. We also maybe want to do it, we may want to do it on the graphics card, not on the CPU. So there's a lot. Yeah. Robot Chocolate Dino, off topic, but how do you stay motivated on long projects like this? I usually would lose interest much earlier. I'm wondering if there are techniques. So let me say two things. First, let me answer your question for actual long projects, and then let me give a caveat for Handmade Hero. So for long projects, I would highly recommend watching John Blow's presentation on this. He actually gave a presentation on not necessarily motivation, but just mental states, right? Like how to deal with your mental states. And he talks about some of the basics of that you should know. And I would recommend that. He's worked on multiple very long game projects that were very difficult. The Witness in particular was like, I don't even remember how long it was, 7 years. Very, very long. And it's an amazing game at the end. So it wasn't like it was a struggle project in a way. It was like, it just really needed this much time to be done by the number of people that were on it, you know? So I would reference that. people in the chat can probably point you to the actual YouTube video, but just it's Jonathan Blow's lecture on like mindfulness, basically, on managing your mental state. But the other thing I would say is I would really encourage people to remember that Handmade Hero is not a long project. Handmade Hero has barely had any programming on it at this point. I mean, we are talking about a few hundred hours. I don't know what it is, 700-800 hours of programming. That is child's play on a project. I mean, I've never been on a project that shipped that was that little programming, right? You might find one if you're using a pre-built engine, because then you're just maybe not doing much programming at all. Maybe you're just like instantiating a typical first-person shooter with the Unreal Engine and just making art assets for it or something. So maybe then there's not very much programming. But assuming that you're actually doing anything real, 700, 800 hours of programming is nothing. I mean, it's a blink of an eye. It's like, what, 20, 30 weeks of programming. It's not even a year of full-time work. And so I would say to people, if the amount of programming that's done on Handmade Hero, if you think of that as a lot, that's probably a good indication that maybe programming isn't for you, right? That should be a very small amount of programming. And if you're early on and you haven't had much programming experience, then that's okay. But just like if you're not thinking, oh yeah, I'll get up to that point eventually and that'll be a reasonable amount of programming for me, that's probably a bad sign. You don't really want to be having those thoughts if you're going to be an engine programmer. Engine programmer should not think the amount of code on Handmade Hero they've done is much, because it isn't. There's just not that much coding work that's gone into this project, if that makes sense. It's very low. It stretches out over a long period of time because I only do a few hours a week, but that's not hard, right? That's just, it's easy to say, oh, I just spent 2 hours a week on it, and I spent them, so that doesn't really wear you down mentally, because you're hardly putting that many hours of work into it anyway. How big is Handmade Hero? Don't we have... Okay. What's it doing? Okay, there we go. Handmade Hero is 28,000 lines of code. Is that correct? I mean, it depends on how you want to count it. I don't know if you want to count comments and stuff like that, or blank lines, right? But assuming you're just talking about lines of code, looks 28,000. And I think that includes Handmade Ray, probably. Does it? Okay, no, it doesn't. Okay, so it doesn't include Handmade Ray. So that's a fair estimate. So again, like really not that big, right? 30,000 lines of code is just not a lot of lines of code. Did you ever get burnt out? What does it take for that? Have you noticed a change in your mental stamina as you've gotten older? Not really, no. If anything, I think my mental stamina has gotten better as I've gotten older. For better or for worse. I don't know if that's a good thing. But I'll stick with things longer now than I used to, probably. I don't really get burnt out. I do get scared. So I get really scared about not having enough money to finish something or stuff like that. I get terrified about those sorts of things routinely, like every couple of weeks. When I'm working on stuff that's not like somebody else paying me a paycheck to do a specific piece of code. So I get scared a lot, but really not burnt out. If I was independently wealthy, if I just had like billions of dollars or something sitting around in a bank account, I'd never burn out. I don't think. I'd just be happy as a clam programming away, and I wouldn't even care if it ever shipped. That's just because I like the act of programming. So if I don't have to worry about it, my mental state is very good. It's when I have to worry about actually delivering something that I get scared, and I think with good reason. Like, I think anyone should. It's hard, and it doesn't often go well. A lot of games don't make money anymore. There's a lot of reasons to be scared. I think it's totally reasonable. So I don't fault myself for that, and I don't think there's a lot you can do about that. I think it is scary. It's like skydiving or something, right? It just is inherently scary. It's something humans weren't meant to do, and so you're kind of pushing a little bit of a emotional limit there, no matter what you do. Burnout is a different thing, and I don't really feel like I have that very often. I definitely have some bad mental states I get into, but they're usually fear and not exhaustion, is I guess what I would say. That's just me. How long does a full rebuild take? You just saw it many, many, many times. Every time we hit build, it's a full rebuild. So, I mean, if you want to see it, that's the full rebuild. If the game isn't running, it might be slightly faster. I'm not sure, because our game takes up a lot of CPU, so I don't know how that affects it. Yeah. So it's a faster if you're not running the game, because then the compiler isn't fighting for time. But 4.5 seconds full rebuild. That's with optimizations on, by the way. With debug build, I think that drops to 2 point something. So. Pythno says, motivation, I can recommend your chat about the imposter syndrome. It helped me a lot. I used to have way too high expectations of what I can do in a day. I reduced that expectation and set myself smaller goals for each day. Way easier to even start then, and I was surprised how quickly I got way more done than I initially wanted to do. I don't remember where that chat is. If someone wants to post on YouTube, it must be one of the Handmade chats. Yeah, imposter syndrome was something that word was not really used when I was growing up. And I really don't know how useful it is. But yeah, I think in that chat I just covered some basic things. Like, I would ignore that concept almost entirely, and just focus on the fact that, everyone is always learning, and this is a very incomplete discipline. And so hopefully in watching streams like these, you can see that it doesn't really matter how long you've been programming. You will still make mistakes. You will still need to explore to find good solutions. You will still be stumped from time to time. You will still have to accept imperfect solutions. And that's one of the main things I wanted to show on this stream to begin with. And so I feel like imposter syndrome is something that we should just banish, even from something people should worry about. I think if you're feeling like you're not able to do the job, I think you have to remember that, like, this is a very hard discipline that everyone struggles with, and that's not just you. And there are lots of concrete ways that you can get better at things, and we all are trying to do those things. And there are no programmers out there who are just magically awesome at everything every day. It simply is not the case. I have worked with many of the greatest programmers in the game industry I've worked with, and they all are that way, right? It's very hard. And so rather than thinking about imposter syndrome, I would more say realistic expectations. Don't imagine that the people out there who have been doing this job longer and do it better than you or something are doing something magical. They're only a little bit better. and you can get there if you practice, right? And so, yeah, I mean, that's one of the reasons I think it's great that there's more programmer streams now, so that you can watch and internalize that. You can see programmers who you may have respected and thought never made mistakes or were just doing some magical thing that you could never do. You can see them like being stupid on a stream and making a dumb mistake and taking an hour to find a bug that should have been obvious and all sorts of, it's like that's programming is complicated, and it's something that you have to constantly work at, and do not set the bar unrealistically high for yourself. It's not that kind of a thing.
Do you ever experience having no idea on how to approach a specific problem and have that negatively impact how productive you are? Any tip on how to deal with it?
So I guess I do have a tip on that. So when you are trying to solve a problem that you don't know how to solve, the best advice I can give is try a lot of things. What I see a lot of programmers do that I think is bad, is a bad habit in that situation, is they try to figure out the solution before they start typing. There aren't very many hard problems in programming that you can figure out the solution before you start typing. Now, sometimes there are if it's math oriented, but then my answer just becomes start writing, right? Start working the math. And the reason I say that is because if something's solution or mathematical representation is not immediately obvious to you, it probably isn't immediately obvious, period, and you're going to have to do exploration to find it. So the wrong thing to do is to stop programming or stop writing math and think about the problem. The reason for that is because your brain obviously isn't good enough to jump to a solution, and that's fine. Use the tools you have to explore the problem until you find a solution. Make visualizations. Draw everything you possibly can that relates to the problem. Make simulations of the problem. Collect data from those simulations. Graph them, right? Look at everything you can. If it's math, work through the math. Use MATLAB to graph the math. Solve the math in multiple ways, right? Go find math books on the topic. See if there are ideas in there that you don't know about, right? Get on Google Scholar. Look for research papers involved. Get going. Do something, right? Build something. And usually the solution will come out of that. The times that stumpers remain stumpers is when you remain paralyzed, when you don't do something. And so I can't recommend highly enough the act of active programming, active problem solving, whether that be writing more equations, making more graphs, collecting more data, writing more code. Do something. And that is almost always the route to the solution. Sitting there contemplating it in your head is rarely the thing. And what you'll often find too is you may then think of the answer. The answer may come to you in your head as if you thought of it, but that moment only comes because you've been working the problem, right? And so that active behavior actually stimulates your brain and provides more context and more ideas for it to chew on, and then that idea may come. Right? All right, I'm going to roll it up. All right, thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you want to follow the series at home, you can always pre-order the game on handmadehero.org. It comes with the source code so you can follow along with it. We will probably be on Christmas break for a while. I will be away for Christmas, and so winter break might go till January 10th, 15th, something like that. So it'll be 2 or 3 weeks before I see you again. Don't let that stop you. Whatever project you're working on right now or program you're doing, do some good programming over the winter break. Spend some time doing some cool stuff and learning about programming. And then when we come back, we'll have a whole bunch of stuff we can do on Handmade Hero. We can play around more with the camera code. Then we can get to some stuff we've been wanting to get to for a while. Just throwing in some nice stuff, ground cover. We can maybe look at the lighting a little bit. Just tie up the game look. Get it looking like a real game, because we're pretty close to that actually. And then I think we can finally check that box and say it's all gameplay from here on out. That'll be a bad day, because I don't want to do game design. I'm not a designer. So, I'll do everything I can before we get to there. But at some point, we're running out of things that are engine side. So we got a few more things to do there, but we're going through them pretty well. And so we'll see. And hopefully when we come back to, we can get the Twitch stream set up a little bit better. We're going to put some emojis in there, custom emotion, custom emoticons, and custom badges and stuff. So now that we're Twitch partners and all that stuff, we can set all that up for you guys too. So that'll be coming when we come back from Christmas break as well. All right, everybody. Have a good holiday season. And and regardless, have a good break, even if it's not winter where you are, or if it's not holidays where you are. Have a good couple week break, do some good programming, have some fun, and I'll see everyone when we come back. Thanks, everybody.